Okay, so the last thing that we have to explain is how to determine if function is even, odd, or neither, if it's a rational equation. So it's going to have the same basis if if f of negative x is equal to f of x, then it's going to be even. If negative f of x is equal to x, then it's going to be odd. And then if neither one works, then it's going to be neither. So what you're going to do is you're going to replace all the x's with negative x, and then you'll factor it out on both sides, and then you'll take out a negative 1 at the end, and if that equals what you had in the first place, so that would be f of negative x because you've taken out the negative 1 from your equation. So if that equals what you had in the first place, then it's even. Now, if it's odd, it's going to be because, for example, the top was even and the bottom was odd, or the top was odd and the bottom was even, so that when you pull out negative 1, it's still different. So then that's going to be negative f of x because you're only taking out one of the coefficients in the irrational. So that's going to be odd. And then neither is if either the top or bottom is neither, then your final equation will be neither. So that is how to determine even, odd, or neither based on a rational equation.
Okay, so I'm going to teach you about even and odds, the trick of even and odds. So when you're looking at equations, if all exponentials are even, meaning 2, 4, 6, 8, then the function is even. And if all exponentials are odd, as in 1, 3, 5, 7, 9, then the expression is odd. But if it's mixed, as if in some exponentials are even and some are odd, then the function is neither. So we're going to do some problems. So when you have just an x, it's really x to the power of 0.
1.
1.
X to the power of 1. Not 0. Common mistake, though.
That's true.
0 is neither even nor odd.
But 1 is odd, so therefore the function y equals x would be odd. But if we come over here, and y equals x squared, 2 is even, and since it is the only exponential in this function, the function is even.
That is nifty.
When you come over here, you would have to, because they're being multiplied, you would have to add the exponentials, and there you would get x to the 7th.
Because that is only one term when they're being multiplied together.
That's true. And because 7 is odd, the function is odd. Let's look at neither. Here we have x to the 5th minus x squared. And 5 is odd, and 2 is even. Therefore, because you have an odd exponential and an even exponential, it would be neither.
That's true. And if you ever had any questions, you could just graph them. So like on f of x equals x, then you could just graph it and see that it's obviously odd because it's a reflection.
Of course.
Or rotation over the origin, not a reflection, because that is wrong. Now, if you go down here to like x plus 3 squared, then that's a more difficult problem. And that would be even because it's only one term.
No, that's wrong, Andrew.
Oh, no, that's wrong. Tell me why.
Well, you would have to multiply out because it's squared. So you have to FOIL it out. And
oh, you have to FOIL it out.
You would. So it would become x squared plus 6x plus 9. And
yes, indeed it would.
Therefore, it would be neither.
Because there's an x to the first and an x to the second. Wow.
That's true.
That must be a common mistake that lots of students make on the test.
I'm sure it is.
Well, I think we've all learned a lot today.